Hello, everyone. Thank you for giving me the opportunity to present my work on flexible and scalable annotation tool to develop scene understanding datasets. I'm MD Fazlilahi. I'm a graduate student. I'm under the supervision of Dr. Renrantian and Dr. Shaulo. We've been lucky to be advised under the mentorship of Dr. Britt Youngman. Uh, this is my overview of the presentation, and I would mainly emphasize on the tool we are proposing to develop the scene understanding data set. To give you the background about scene understanding task, it's when we ask a model a question about scene, we expect that it can answer any type of questions. But recently, the scene understanding task has extended beyond recognition to for the models to require the cognitive ability. For example, the models not only need to recognize the objects but also need to reason over the interrelation between the objects to answer these questions. So these questions require, other than yes or no, it requires complex reasoning. Some of the examples could be visual question answering, visual common sense reasoning, and co-reference resolution, and so on. And to support the development of such models, we need the data and we need the labels or annotations that provides both the level and also the uh, the the knowledge, the human intelligence, so that it can be transferred while training the model. So we believe that a configurable data collection user interface would be required, and because of the limited support in freeform annotation of the existing tools, we have we are proposing such tool. To give you an example about how what type of challenging scene understanding task would be, like if a human is asked to answer a question about about this particular scene, that what the person is eating, so and it's pizza, and most of the models can answer it. And if we ask why the human thinks that it's the pizza but not the burger, then the human will come up with some explanation that requires some reasoning other than recognition only. Now, if we want similar explanation from the AI models, then we need to need some way to transfer this knowledge to the AI through the training data. And we believe one way it could be like the labels and also the explanation behind those answers. Like and if we connect the parts in the explanation where the human would have emphasized, then in terms of text and visual objects in the image, uh, then there is possibility that the knowledge would be transferred to the AI. And we see that, for example, here we see that pizza slices and eat, they represent different in text, but they point to the same visual region in the image. And also that we need some freeform annotation, because all the text parts that have been labeled are objects. But what if the research question requires to focus on activities? The person is not holding the burger instead of those objects. Then we need some way to label the activities. Hence, so that's why we think we need such freeform annotation, and this type of annotations are known as object level grounding. And there are active development of some such data sets because of its popularity. Now I would like to introduce the features of our tool, that it provides flexibility in the sense that the researchers is given a user interface to design the data collection user interface to collect the data from the labelers, and it would support the labeling or annotation capability in terms of modules. For example, it could be timestamp marking, spatial annotation, and freeform text annotation. And it also features the scalability because computer vision tasks can require a lot of data points. So it is supposed to be, could be it could be deployable at various scales. Now there could be some research question. For example, if we want to develop some model that can read X-ray diagnosis, we need data from experts instead of crowd workers. So the data collection user interface can also be hosted in a private server and can be distributed to the target expert. And also for crowd data collection, we can use MTurk. So to give a high-level overview of our data collection process using the tool, a researcher would use the layout designer to collect the to design the annotation or data collection interface, and they can include the images or videos, and they can add the questions, question answer blocks that could be free form or MCQ or additional custom modalities. And after designing the annotation interface, it can be deployed in Amazon Mechanical Turk or private server according to the research questions. And here is a demo that shows how we can we use our tool to oh, doesn't play. Oops. Sorry. Okay, so here actually the video is supposed to show that we can choose if I am a researcher, I can choose a file or like list of files. It could be images or videos, and then we can add the functionalities, maybe the OLG, and we can connect. We can add the modules that can map the text and objects that just I have shown the person eating pizza that can be implemented using this data collection user interface. And this one is after a researcher designs the tool, design the data collection interface. If they want to deploy, they can save the user interface layout, and then with a minimal configuration, they can deploy it in MTurk, or it would be in their local or in the lab machine to control the distribution of the data collection. And we conducted a case study using a prototype user interface for conducting a human behavior experiment. It's mainly the participants are shown a video that has been recorded from a car's dashboard camera and asked to segment the pedestrian's crossing intention. They are asked a question that if the person would cross in front of their car or not, and they are after their answer, they can explain. So the answer requires complex reasoning. So around 74 people are participated in the study, and 24 people used without OLG functionality, and 50 people used OLG. So we used OLG to see that if it affects the annotation quality. Now this is how we configured the data collection interface, where we add the question answer modalities, some multiple choice question format, and some are free text, and there are also support to connect the text chunks to the that is the support of OLG is also given. And then this is the annotation output when a participant tells that they are not sure about the person crossing in front of the car, and their explanation and how it is connected to the how the texts are connected to the visual objects. Now we conducted a evaluation, user attitude, user experience, and through a qualitative survey. 11 questions were asked, and mostly has shown positive attitude towards the user experience, but there is room for improvement. And for our experiment, we believe that the annotation quality metric depends on the number of word counts, in the sense that we wanted wanted the people to explain as much as they can. So that's why we have chosen this metric, and we saw that the people with OLG support have higher word count to describe for each video. And to conclude, we have proposed a tool to improve the data collection process to support the dataset development that can help with developing the models with complex reasoning. We have shown that the comparison to show better annotation with OLG functionality. And this is an ongoing work, and it has room for improvement, like to expand the customization support and building modules. And also there is a good scope to research with how the levelers interact with the data collection interface for extracting better data. I would like to thank our mentor, and we acknowledge the funding support from Toyota Collaborative Research Center. And I thank you for hearing me out. With this, I would like to conclude.
Hi, that was very interesting. Can you talk a little bit about the opportunities for transfer learning from like other image style data sets? So, you showed that this annotation system is really meant for like real world video scenarios, it seems. But in your earlier example of the boy holding the pizza instead of the burger and so on, it seems like there's some semantic relationships, like the fact that pizza is a triangle, or the fact that eating means it's near a mouth. These are kind of conclusions that you might be able to derive from other data sets, like either from, potentially from just images that you crawl on the web. You don't need a lot of like real world video to figure out that pizza is triangular, or that eating happens near a mouth, right? To what extent can you use information sources that are not directly in the video stream in order to improve accuracy, or to give like default labels to the person using your tool?
If I understood, that's a good question. If I understood it correctly, so we believe that there are these models which can already recognize the objects in the video, but it could be the cases that if the research question demands that it focuses on something different other than what the existing models know, then I think then we need some way to label those with flexibility. So I think that's the tool can help with to annotate the data.
Maybe another way of asking this question is, what's the piece of information that this tool is uniquely good for getting at, right? Is it the relationship between objects in a complex video space? Is it just recognizing a human in a complicated image? Like, what do you think is the piece of information that we get from your tool that's very difficult to get through any other mechanism?
That would be mainly the connection between the visual region and the text chunks in the explanation. So we think this information actually reflects in the explanation where the human focuses on when they provide their reasoning.
Okay, great, thank you.
Hi, thanks for the talk. I really enjoy your talk. My name is Jen from NYU, and I just noticed that, like, in your evaluation part, you said compared with the baseline, your tool, like the users who use your tool, have 30%, 35% more informations from their annotation. So I just want to know, I'm just curious about what kind of informations are added and whether you, how do you validate the actual information, like from the labelers who use your tool? Yeah, thanks.
Yeah, so we wanted the actual, we wanted an explanation to the actual, so that they can support their simple yes/no answer. So we evaluated the answer manually because we had some guidance on that, like how to explain. Now, if they are relevant, we have considered those as actual, like those words that support the explanation.
Can you give me an example, like say what kind of information are added?
I would say in our case, we actually we ask a participant like that if they see a person standing or waiting to cross the road. Now they are asked that at that moment, would that person cross in front of your car? Now they will say maybe no, because they are waiting on the curve of the road, and that is some factor that they are standing. So those activities are those activities in the text explanation reflects their explanation behind what they decide about the crossing intention of that person.
Okay, thanks.
Thank you again.